Good morning. My name is Efoma Ibude Innocent, and my team member is Agbaraji Emmanuel Chukwudi. Our team is computer vision tasks in recent development in model architecture in vision tasks. So we'll be presenting our model, and then during the presentation, I'll be taking the install packages, running the codes, and also taking the install packages. Also go down to explaining the imported libraries, why we choose those libraries, their function, our codes. Also go down to the loading, the cipher 10 data, and also the processing. So that's what I'll be taking during this first session of our presentation within the next 10 minutes. Okay. Now we have our install packages. We have to install Touch. We also have to install Touch Vision. We also have to install uh, Adapt Believe PyTouch. Adapt Believe PyTouch is also one of the recent development in computer vision. One of the very reliable optimizer that we got to find out during our deep research as we were looking out for solutions in tackling the task we had at hand. So that's for Adapt Vision. That's for Adapt Vision. So for the PyTorch, for the Torch, you have to install the Torch because PyTorch is widely used for applications such as the computer vision and also for natural language processing. This is because of its flexibility and also the ease to use, especially in creating deep learning models as well. It also provides rich APIs for deep learning, but also for the gradient-based optimization data handling. That's actually one of the foremost reasons why we have to install PyTorch. Then also for Touch Vision, the Touch Vision is actually designed to help with loading and pre-processing common data sets for computer vision, as well as for building and training image-based deep learning models. The Touch Visions also support for loading several standard data sets, image transformers, and also offers pre-trained models which are also actually based on popular architectures. Now for the Adapt Believe PyTorch, Adapt Believe PyTorch is actually an optimizer that is part of the family of the adaptive learning rate optimizers. Okay, the key concept behind the Adapt Believe is actually to adapt the learning rate based on the belief in the observed gradient. It also helps to adjust the step size by the square root of the estimated second moments of the gradients. Those are actually some of the benefits of Adapt Believe Optimizer. So we have to run that now. Okay, yeah, run. Safe and good to run. So we're running installing our packages. So while we wait for a moment so that the packages can be fully installed. All right, installing. Our packages are installing. Okay, it's taking a while. Okay, while it's installing also, I'll also be talking about our imported libraries. So we also have to import the touch, which I have talked a little about the touch. We also have to import the touch.nn as nn. We also have to import an optim. We also to import a function, a touch.nn.functional. That also have to import that as f. The touch vision as also the touch.transform as transform. The touch vision dot datasets as datasets. We also have to import the touch utils dot data and also as data loader as well. So what we will take time to explain all the data sets and what they actually do. Okay, our packages have been fully installed. Now let's install the libraries too. So that of the touch is actually essential for most of the PyTorch operation, so are the tensor creation and also operations that are fundamental in building a neural network. The touch.nn as n actually import the neural network model from PyTorch. This model actually includes all the building blocks for creating neural networks like different types of layers. Then the touch.optim as optim actually imports the optimization model. The touch.nn.functional as f. This provides access to several functions that are commonly used in neural networks. Okay, so we are done with installing. Okay, let's also install this as well. The print, amazing. That's pretty fast. We're done with that. So let's install our CFI data and processing. Okay, so once this is done, I'll be handing over to my colleague, Agbaraji Emmanuel, to take over from there. Okay, Emmanuel, please take over.
Okay, my name is Chukwudi Emmanuel Agbaraji. Starting from the neural network and Python design, that should be after the loading of CIFAR 10 data and pre-processing. So the CIFAR 10 dataset is actually a dataset that contains varieties of images and is commonly used for computer vision tasks. So for the neural network and Python design, the network used in this work is the CNN network, and the activation function used is the ReLU activation function. For the training, the neural network. For the training of the neural network, we have the first point is to define the optimization. That is after the design of the neural network. We defined the optimizer. So the first optimizer we used or we applied in this work is the Adam optimization method. So going back to the neural network and PyTorch design, we have to run the code. Now our code was successful and we have to move over to the function, that's defining the loss function and optimizer. So the optimizer applied here is the Adam optimization method, which is the initial optimization method used in the work we started with. So in applying the Adam optimization method, about 5 epochs was executed. And in order to make it easy for our work, we had to create a saving path for the trained model to be saved. So the next point is the prediction. So at the prediction, we had to recall back the saved model, which is now being used. So uh, running the optimizer was successful. From the screen, it can be seen that is successful. And the epochs, running the epochs will take a longer time. So which we may not be able to wait because of our timing. So since we have run it already on Google Colab, we are going to use the results we got to finish the explanation. So going to the prediction, for the prediction, based on the Adam optimization method, the from the loaded data set, which was divided into train and test data sets, the prediction now will be using the test data sets. So after running that, we got an accuracy of 0.5919, which is approximately 59% accuracy for the Adam optimization method. So to clear clear doubts, we had to bring in confusion matrix, which was used to know the accuracy, precision, stability, and generalization of the model. So this was run, and the same process was repeated using Ada belief optimizer, and the number of epochs used for the training is or was five epochs, and the trained model was also tested for accuracy, precision, stability, and generalization. So from the results, the Ada belief achieved 0.6978, which is approximately 63% accuracy. And looking at the confusion matrix, the Adam optimization method achieved lesser accuracy in the number of correct predictions. So out of 10 predictions carried out for the 10 classes, Adam optimization method was able to achieve more correct or higher correct predictions in 3 classes, while the other belief achieved 7 higher correctly predicted images in 7 classes. So in accuracy, other belief achieved higher accuracy compared to the Adam optimization method. So in conclusion, it was this it was concluded that the Ada belief achieved better optimization for the model in computer vision tasks than the Adam optimization method. Thank you.
All right. Thank you. So that's that from us.